Fact number 1. What keeps the sun shining? The sun shines due to nuclear fusion occurring in its core. This process is called thermonuclear fusion. The primary element involved in this fusion is hydrogen, which fuses together under immense heat and pressure to form helium. This fusion reaction releases an enormous amount of energy in the form of light and heat, which is what makes the sun glow and emit radiation. The process of nuclear fusion in the sun involves 4 hydrogen nuclei, protons, coming together to create one helium nucleus. This reaction releases a large amount of energy according to Einstein's famous equation, E equals mc squared, where E is the energy released, m is the mass difference between the reactants, hydrogen, and the products, helium, and c is the speed of light. The energy produced by this continuous nuclear fusion reaction is what sustains the sun's brightness and heat, making it shine for billions of years. The sun has been shining for about 4.6 billion years, and it is expected to continue shining for several billion more years before it exhausts its hydrogen fuel and transitions into the next phase of its life cycle. Fact number 2. Why is the ocean salty? The ocean is salty primarily due to the process of weathering and erosion on land. Here's a breakdown of how this happens. Mineral dissolution. Rainwater is naturally slightly acidic because it absorbs carbon dioxide from the atmosphere, forming a weak carbonic acid. As this rainwater falls on the Earth's surface, it starts to erode and dissolve various minerals present in rocks and soil. The most significant contributors to ocean salinity are the minerals containing sodium, Na, and chlorine, Cl. Rivers and streams. The dissolved minerals are carried by rivers and streams from land to the oceans. As these water bodies flow, they pick up more minerals along the way. Eventually, they deposit their load into the ocean. Volcanic activity. Volcanic eruptions also release various elements and minerals into the atmosphere and, consequently, the oceans. Volcanic rocks contain a wide range of elements, including sodium and chlorine, which contribute to the salt content in the oceans. Hydrothermal vents. These underwater geysers are found in certain areas of the ocean where tectonic plates spread apart. They release superheated, mineral-rich water into the ocean, adding to the salinity. Evaporation and seawater circulation. Water evaporates from the ocean surface due to the sun's heat, leaving the salt behind. However, the salt does not evaporate and remains in the water. The remaining water, which now has a higher concentration of salt, becomes denser and sinks, causing circulation patterns that distribute the salt throughout the oceans. Over millions of years, these processes have contributed to the accumulation of salt in the oceans, making them salty as we know them today. The exact salt content can vary depending on factors like location, climate, and local geological conditions. Fact number 3. How are caves formed? Caves are natural underground spaces, or hollows, that are formed over long periods of time through various geological processes. There are several ways in which caves can be formed, and the most common types include solution caves. These are the most common type of caves and are formed in soluble rocks such as limestone, gypsum, or salt. Rainwater and groundwater that contain weak carbonic acid seep into the rock through cracks and fissures. Over time, this acidic water dissolves the rock, creating passages and caverns. As the process continues, these passages may widen and develop into large cave systems. Lava tube caves. These caves are formed when lava flows during volcanic eruptions. The outer layer of the lava cools and solidifies, while the inner part continues to flow. When the lava flow stops, the remaining molten lava drains out, leaving a hollow tube-like structure. Lava tube caves can be quite extensive and are found in volcanic regions. Sea caves. Sea caves are formed by the erosive action of waves along coastlines. The constant pounding of waves against the rocky cliffs gradually wears away the rock, creating cavernous openings. Sea caves are typically found in areas with softer rock formations. Erosion caves. These caves are formed through various erosional processes, such as the action of flowing water, wind, or glacial movements. Over time, these forces can carve out underground passages and caves in different types of rocks. Tectonic caves. Some caves are formed due to tectonic activity, such as the shifting and folding of rock layers. As the Earth's crust undergoes movements, fractures and faults can develop, leading to the creation of cave-like voids. It's important to note that cave formation is a slow and gradual process that takes thousands to millions of years. Caves can vary greatly in size, shape, and complexity, and they often contain unique geological features and formations like stalactites, stalagmites, flowstones, and cave pearls, which are created by the deposition of mineral-rich water.